Hi students, good morning to all of you. Today we are going to discuss about hybridization part 2 with the different examples. In part 1, I gave a simple super trick formula. So by using that one, today we are going to discuss about different examples. Right, okay. So first one, beryllium chloride, Bcl2, central atom beryllium, bonded atom chlorine. What formula I give? Number of atoms attached to the central atom. How many atoms are attached here? There is 2. That are only bonded atoms. 2 plus next lone pairs. So lone pairs of electrons on beryllium central atom. So how to do lone pairs? There is number of the valence electrons of beryllium 2, and next minus number of bonded atoms are 2. There is 0. So in this molecule beryllium don't have any lone pairs of electrons. There is 2 plus 0. Then the value will get 2. So that is called hybridization number. If hybridization number is 2, then the molecule undergoes sp hybridization. One s orbital, one p orbital. Okay. Next one, boron trichloride, Bcl3 molecule. In this molecule central atom boron, bonded atoms chlorine. How many are there bonded? 3. Okay. Then here the lone pairs of electrons. So lone pairs of electrons and boron. So boron, how many valence electrons? 3. Then number of bonded atoms also 3. 3 minus 3, 0. That is the value of lone pairs is 0. So 3 plus 0, that is 3. Then the molecule undergoes sp2 hybridization. sp2 hybridization. Got it. Next one, another molecule. Take it, methane molecule. Methane, central atom carbon, bonded atoms hydrogen, how many? 4. Then lone pairs of carbon atom. So carbon valence electrons 4, bonded atoms are also 4. Then 4 minus 4, 0. That value you have to apply it here. Then 4 plus 0, 4. Then you get the molecule undergoes sp3 hybridization. Next one, there is Chloroform Chcl3. Here the carbon undergoes what type of hybridization? This previous question. Central atom carbon, bonded atoms 3 chlorines plus 1 hydrogen, totally 4 bonded atoms, plus lone pairs of carbon. So carbon having valence electrons 4. Next minus bonded atoms 3 plus 1, 4. 4 minus 4, 0. So that is bond pairs plus lone pair. 4 plus 0. Then 4 value. Then you will get the molecule undergoes sp3 hybridization. Next molecule is take it here, ammonia molecule, NH3. Here central atom nitrogen. Okay, so bonded atoms hydrogens 3 are bonded, and lone pairs are nitrogen. Then nitrogen valence electrons 5, my dear students, and bonded atoms 3. So 5 minus 3, 2 electrons. 2 electrons means how many pairs? 1 pair. There is 1 lone pair of electrons that you have to apply here. So 3 plus 1, then you will get 4. The value is 4 means the molecule undergoes sp3 hybridization. That means in ammonia, nitrogen having 3 bond pairs and 1 lone pair. Okay. So that is totally the molecule in which the central atom nitrogen undergoes sp3 hybridization. sp3 hybridization. Next, another example, ammonium ion, NH4 plus. It is ammonia, it is ammonium ion. The ammonium ion, nitrogen undergoes what type of hybridization? Central atom nitrogen, bonded atoms, hydrogens 4 are there, plus lone pairs, how many are there on nitrogen? So nitrogen valence electrons 5, okay, in the free state, valence electrons on nitrogen. Then here it loses 1 electron, right? So that electron is not there now in this molecule. So that you have to subtract it. That is minus 1. So this is the charge. So this is a cation part. The charge part is a positive. The many number of electrons it loses. That is 5 minus 1. You get that is 4. Then bonded atoms 4. So 4 minus 4, 0. 4 minus 4, 0. Okay. 4 minus 4, 0. Then you get that value you have to apply here. That is 4 plus 0. Then the value you get, that is 4. Then the molecule undergoes sp3 hybridization. sp3. 1 s orbital, 3 p orbitals, totally 4. That is sp3 hybridization. Got it. So here, if you observe the difference here, in ammonia molecule, bond pairs 3, lone pairs 1. But in ammonium ion, the bond pairs are 4, lone pairs are 0 only. Right. So that there is a difference here. So but both the molecules, the nitrogen undergoes sp3, but number of bond pairs and lone pairs difference is there. Next, another molecule, there is a NO3 minus. So cation I gave, now anion will do one example, right? Or some examples also. It is a nitrate ion NO3 minus. So here central atom nitrogen, bonded atoms oxygen. How many are there? 3, and lone pairs. So lone pairs are nitrogen. Okay, and nitrogen having valence electrons 5. Next, it carries -1 charge, means it gives 1 electron. That electron belongs to that molecule now. So that's why that you have to add it. That is +1. So that is the in case of anion, the charge number you have to add it to the to get the to calculate lone pairs of electrons. And then, so I gave a note in the first part. You just watch that video also, you will get the clear concept. First you watch that video first part, then you can watch it. It is very easy to understand, my dear students. Okay. So then, and as a note I give, in case of oxygen atom is present, for each oxygen atom, we have to consider 2 electrons. Here 3 oxygen atoms are there. So 3 into 2, 6 electrons. So that 5 plus 1, 6 minus 6, 0. So that is lone pairs of electrons are 0. So 3 plus 0, that is 3. Then the molecule undergoes sp2 hybridization. Next one, NO2 minus. NO2 minus. These are previous year questions, that is. Okay. So PYQ. Alright. Then NO2 minus, central atom nitrogen. So that is bonded atoms 2 are there, oxygens. And the lone pairs are nitrogen, how many? That is valence electrons of nitrogen 5. And it is a anion, it gives 1 electron +1. Then oxygens 2 are there. So for each oxygen 2 electrons, 2 into 2, 4. That is -4. Then 5 plus 1, 6 minus 4, 2. 2 electrons means how many pairs? 1 lone pair. So that we have to add it. So 2 plus 1, 3. 3 means the molecule in which the central atom undergoes sp2 hybridization. So here you can observe the difference in these two, my dear students. What you will get it is, in NO3 minus, bond pairs 3, lone pairs 0. But in NO2 minus, nitrate ion, bond pairs are 2, lone pairs are 1. 1 lone pair is there. Got it? Okay. So they will frame the questions like this. Which among the following anion having 1 lone pair of electrons? Okay. Got it? Right. Next one. Another molecule, there is Clo4 minus, anion and given down. Okay, so here the chlorine undergoes what type of hybridization? So chlorine central atom, so there is bonded atoms, how many? 4 are there, plus the lone pairs of electrons are chlorine. So there is chlorine valence electrons, 17 group elements, there is 7 valence electrons are there. Okay, and then so there is gain 1 electron, that is +1. And then this part, it is gaining anion, means you have to add that electrons. Got it, my dear students? Okay, then this is for 4 oxygens are there. For each oxygen 2 electrons, 4 into 2, 6. 4 into 2, 8. So then 7 plus 1, 8. 8 minus 8, 0. 0. Then the lone pairs are 0. So 4 plus 0, 4. 4 means the anion undergoes sp3 hybridization. You're following, right? Okay. Next, Clo3 minus. Then here chlorine central atom, oxygens how many? 3 are there. Then lone pairs on chlorine, that is chlorine's valence electrons is 7, and here it gain 1 electron, that is +1, and 3 2s are 6. Then 7 plus 1, 8 minus 6, 2 electrons. 2 electrons means how many pairs? 1 lone pair. So there is 3 plus 1, 4. So that it is undergoes sp3 hybridization. Then we get here Clo2 minus. So central atom chlorine, bonded atoms how many are there here? 2 bonded atoms are there. Then lone pairs on chlorine atom, lone pairs are chlorine, valence electrons is 7, and it gain 1 electron +1. And for 2 oxygens, each oxygen 2 electrons, 2 oxygens 2 into 2, that is 4 minus 4. Then you get 7 plus 1, that is 8 minus 2, 8 minus 4, 4. So 4 electrons means how many pairs? 2 pairs, 2 lone pairs are there. Okay, my dear students, this one is 2 lone pairs, 2 lone pairs. Then that value have to add it here. Bond pairs 2, lone pairs 2. Then totally 4. Then the ion undergoes sp3 hybridization. Okay. And number 12 example, that is Clo minus. So here the chlorine undergoes what type of hybridization? Single atom chlorine, bonded atoms oxygen only one. Next, lone pairs on chlorine atom, valence electrons of chlorine 7. It gain 1 electron, that have to add it plus 1. Next one, that is here one oxygen is there, so one oxygen you have to consider 2 electrons. Then you get 7 plus 8 minus 2, there is 6. 6 electrons means there is 3 lone pairs are there. So 1 plus 3, there is 4. 4 means the ion undergoes sp3 hybridization. Okay, got it, my dear students. See, this is 9, 10, 11, 12. This is previous year question. Okay, they frame the question. The type of hybridization of central atom and number of lone pairs in the central atom of a molecules. These molecules they give respectively. So take care here. Clo4 minus bond pairs 4, lone pairs 0. Clo3 minus bond pairs 3, lone pairs 1. Clo2 minus bond pairs 2, lone pairs 2. So equal number of bond pairs and lone pairs. And Clo minus 1 bond pair, 3 lone pairs. So all non-molecules, the central atom undergoes sp3 hybridization. One time they frame the question, that is, so that is which among the following molecules having equal number of bond pairs and lone pairs. This 4 option 1 Clo4 minus, then Clo3 minus, next Clo2 minus, next Clo minus, or sorry Clo2 minus. Here equal number of lone pairs and bond pairs, that is 2 are there. So like that they comparatively they frame the questions. Got it? Yeah. Next one, another molecule, take it here, xenon Xcf2. Xcf2, there the second atom xenon. So bonded atoms fluorine 2 are there plus. So xenon having how many lone pairs of electrons? So there is valence electrons of xenon 8. So it have 8 valence electrons 8. Next, bonded atoms how many? 2, that is minus 2. So 8 minus 2, that is 6. Okay. So 6 electrons means how many pairs? So 3 lone pairs. So 3 lone pairs, that is 2 plus 3, that is 5. So 5 means the molecule in which the central atom undergoes sp3d hybridization. 1 s orbital, 3 p orbitals, 1 d orbital, totally 5 hybrid orbitals. Then the molecule undergoes sp3d hybridization. Next one, xenon series of the Xcf4, xenon difluoride, xenon tetrafluoride. So here central atom xenon, bonded atoms are 4 fluorines are there. Then the xenon having how many lone pairs? So valence electrons of xenon 8. Next, bonded atoms are 4. That is 8 minus 4, 4 electrons. That means 2 lone pairs are there. So 4 plus 2, that is 6. 6 means here the molecule undergoes sp3d2 hybridization. sp3d2 hybridization. Right. sp3d2 hybridization. sp3d2 hybridization. Right. Next one, Xcf6, xenon hexafluoride. Xenon hexafluoride. Here single atom xenon. So here bonded atoms, how many fluorine 6 are there? Then lone pairs on xenon atom. That is valence electrons of xenon atom 8. Then bonded atoms are 6. So 8 minus 6 you get, that is 2. 2 electrons means 1 lone pair. 6 plus 1, 7. 7 means the molecule undergoes sp3d3 hybridization. sp3d3 hybridization. sp3d3. Right. Okay. sp3d3 hybridization. Next one, Xco3, xenon trioxide. Xco3, xenon trioxide. The central atom xenon, bonded atoms are oxygens 3 are there, plus, so xenon having how many lone pairs of electrons? Xenon valence electrons are 8, and for each oxygen atom you have to consider 2 electrons. 3 oxygens are there, 3 into 2, 6. So 8 minus 6, 2 electrons. 2 electrons means 1 lone pair. So that lone pair, that is you have to add it here. So 3 plus 1, 4. 4 means the molecule undergoes sp3 hybridization. Right. Next one, xenon HCO2F2, xenon dioxide difluoride. So here the central atom xenon, 1 atoms, 2 oxygens and 2 fluorines, 4 plus xenon having how many lone pairs? So 8 electrons, and for each oxygen atom 2 electrons. So 2 are there, 4, and next 2 fluorines are there. So there is 4. That is 4 plus 2. Totally there is 6 atoms. Right. So this is 4 for oxygen and 2 for fluorine. 4 for oxygen and 2 for fluorine. Totally 6. So 8 minus 6. There is 2 electrons. Then there is 1 pair. So 1 lone pair is there. So 4 plus 1, that is 5. So 5 means the molecule undergoes sp3d hybridization. Got it, my dear students? Yeah. So some more examples are there. So I think I'll give as that is as a test. Okay. And some previous year questions that we'll do in the next part. Got it, my dear students? I think we are inside. Okay. So please watch it, and if you like it, subscribe it. Okay, thanks for watching my video, my dear students. Fine.